Okay, it doesn't matter. We're not going to debate it. Okay. So if you see the instruction to find the roots or the roots, however you want to say it, that means, hey, find the x, find where your parabola crosses the x-axis. These are also called zeros. Find the zeros. These are also called solutions. These are also called, you guessed it, x-intercepts. So these 4 words all mean the same thing. Find the roots, find the zeros, find the solutions, find the x-intercepts. That means we are finding where our parabola crosses, or excuse me, intersects the x-axis. Okay? Yes. Yep. Okay, so Amelia just asked a wonderful question. Is that what we were doing when we were finding the zeros on our test? That's exactly what we were doing. Okay, now we were just like setting it equal to 0, and that in your mind was finding the zeros. Well, now graphically, we actually know what we're doing. Okay. Oh, thank you. So if we have 2 solutions, which ones of these graphs is the one with 2 solutions?
This one.
Yeah. So we have a parabola that crosses the x-axis twice. Which one is the one with 1 solution?
This one.
Okay, graph number 4, where we just touch it twice, or touch it once, excuse me. So here, I'm gonna like really point them out. Here, I have 2 solutions. Here, I have 1 solution. If I have a parabola opening up and there's no solution, where does that parabola need to be?
Up higher.
Up higher, above the x-axis. Okay?
No.
Not if it's opening up. If it's upside down, like number 8, and below the x-axis, then there will not be any solutions. Okay? Now, through the course of the rest of chapter 9, we're going to learn 4 different ways to find our roots or solutions, whatever you want to say. Okay? You are going to have a tool belt of 4 different tools to find our x-intercepts. Okay? Today we're going to focus on the graphical part. Tomorrow we're going to go back to chapter 8 stuff. Okay? We're going to learn a formula on Friday, and then Tuesday we'll learn a method. Okay? Now I'm going to back up a little bit. I know we took a quiz yesterday. I had a lot of absences. So we aren't going to get our quizzes back today. I'm sorry. I'm hoping tomorrow. Okay? Then my next thing, our chapter test, our last test, the last grade in the grade book after I put the quizzes in, our test is a week from Friday. Okay? And that's it.
Wait, we don't have a final?
We don't have a final. Isn't that so great? Okay? Geometry does, but we don't. That was bad.
We also do like in Spanish.
Okay. All right. So let's talk about example 1. Okay. Oh, interesting.
Did you still have examples on?
Maybe. All right. So first of all, tell me, somebody in group 1, 2, or 5, how did you come up with this vertex? Abby.
B minus over 2a. Negative b over 2a.
Okay. So we know that for our vertex, we need to do negative b over 2a. So negative 4 over 2 times 1 gave you negative 2. So you're writing this down with me, whether you did with this problem on the board or not. Okay. Now, Kane, I don't know what your group you're in. I don't really care what group you were in. What do I do with the negative 2?
You plug it in.
We plug it in, and it looks like this group, when they plugged it in, got negative 9. Where do you want to go? I think I left it in Miss B. Did you? Okay, it's in Miss Pinkley's room. That's where I ate lunch. Okay, so now let's plug in -3 and -1. Those should have the same values. Do you agree?
Maybe. Yes.
Thank you.
Okay, so it looks like when these groups plugged in -3 and -1, they got -8. Then we plugged in -4 and 0. And I don't know if you have figured this out yet, but plugging in 0 is the easiest thing to do. Because anything with an X is going to be 0, and then we're left with -5. Now, can I tell exactly where we're crossing the X-axis here? No. Oh, you are my hero. Oh, thank you. That actually could be true. What do you think? True, not true?
True.
You wanna do that?
Thank you. Okay, you don't think she'd do that? All right, so let's keep going. Let's plug in 1 and let's plug in -5. If you are, if you have hair that is above your shoulders, I would like you to plug in -5. If you have hair longer than your shoulders, can you please plug in 1?
It's up. Okay. Well, I mean.
Wind down.
Oh, okay.
-5. Long hair, plug in 1. Pull off your wig.
No. Is it above your shoulders? Yes. Hey.
I'm not getting big. I don't want to be Dora.
Okay, short hair. Preston, what'd you get when you plugged in -5? Ooh, he got 0. Okay. Long hair. Peyton W, what'd you get when you plugged in 1? Ooh. So 1, 0, and -5, 0.
It's a parabola. It goes past the X.
Twice. So there's two.
Twice. There's two solutions.
Okay, so Peyton and Preston are tag teaming over here. We have a parabola intersecting the X-axis 2 times. So there's 2 solutions.
You did that.
What are they?
I don't know.
Wait. You read.
Where
X plus 5, X plus 1.
Where do these touch the X-axis?
0.
One.
So it would be
1 and -5.
Ah, here we go. Our parabola touches the X-axis here at 1 and -5. So our solutions are X equals -5 and 1. Let's talk about why these are solutions. What number do we get when we plug these into our equation? 0.
I'm so smart.
Okay, so you're saying okay, so Amelia might be a little bit frustrated right now because she thinks we can just set this equal to 0 and solve. Okay, so let's do this. Come over here. I don't know what's so funny, but stop. Okay, so let's say I set this equal to 0, and then what would you want me to do with this, Miss Amelia? Okay. To be what? No, they're not. One's addition, one's subtraction. What multiplies to -5 and adds to +4?
No. Oh, yeah, no, but
Hmm. So x equals -5, x equals 1. So what we can do is we can come over here and we can plot those points, and we know our vertex has to be in the middle. Okay. Why am I making you graph these again? I need you to understand the visual relationship between what a solution means and what's happening on the graph, okay? And you guys, graphing parabolas, one of the easier things we've done this semester, okay? So let's talk about number 2. In number 2, it looks like graphs 3 and 4 did -b/2a. So they took -b/2a to get a vertex of 1. And right?
Yeah.
When they plugged in 1, they got 0. Okay. Now, when they plugged in 0 and 2, we got 1. Okay. When we plug in -1 and 3, we would get 4. Okay. So here's what our graph looks like, but we need to go the extra step. What is our graph telling us? We want to know where this parabola touches the x-axis, okay? So first of all, Colin, how many times does it touch the x-axis?
1.
No more handing out things during my class. That is a distraction to you, to her, to me, to other people, okay? How many times does it touch the x-axis? 1 time, right here. At x equals what?
Solution.
Okay, if you're having trouble, what could I look at here? Where is the y 0? Gus?
Yep.
Where is the y 0? Where are we touching the x-axis? That is the solution we are looking for. What? You can only have up to 2 solutions in a quadratic because of the square. Now, if we were to graph something with x cubed, then we could have 3 solutions.
Is the cube one where it's like the wavy line?
So a cubic would look something like this. Okay.
But what's the wavy line one? I thought that was.
This,
Yeah.
it's a sine graph.
That's
What's that?
Trigonometry. Okay. All right, so now let's talk about graph 3. If you notice, graphs 6, 7, and 8 are the same graph as what we're gonna do right here. It looks like they took -b/2a, -b/2a to get 1. Right?
Yeah.
And when they plugged in 1, they got -2. Now, this should have been assigned to them right away. My vertex is below the x-axis, and we know that it's opening upside down. so it's not gonna touch the x-axis. Okay?
Snail.
What?
Nope.
I'll do.
So then, if we plug in 0 and 2, we get -3. If we plug in -1 and 3, does that say -6?
It's a 6.
Okay. So this does not cross the x-axis. So we have to say that there is no solution. Our graph does not cross the x-axis. So there is not a number that we can plug in to make this equation 0. It doesn't cross the x-axis. There is no solution.
If we get like to the vertex and then we realize that it's not gonna cross, then we still have to keep going.
Yes.
Right.
Oh man.
Lily wants me to give you something. Hi, Bryce. Hey, Bryce. I'm sorry.
At least get 3 points in it, which would be easy, right?
I'm sorry for interrupting.
Thanks, Lelia. All right. Can you please go to page 17?
Get out.
Okay. Now, I think some of you don't really love the graphing concept. I get it. It is easy, but is it maybe a little bit of work?
Yeah.
Not really. Okay, I like that, Sophia. Sophia's not intimidated at all. Okay, so there is something that we call the discriminant that is going to tell us how many solutions there are without having to graph it. It's not going to tell us what they are, but it'll tell us how many there are without graphing. Okay, and I want you to write this down. B squared minus 4AC is what we call the discriminant.
Okay.
So this is something that's a part of a formula that we're going to learn on Friday. Okay, but this is a discriminant. If the discriminant is positive, then there are 2 solutions. Yeah, we're on page 17. One, I did not. If the discriminant equals 0, there is 1 solution. And if the discriminant is negative, then there are no solutions. Write that down. Okay. So I am just going to ask you to use the discriminant to determine how many solutions there are. It'll help get something out. That is weird. Okay.
You have white earwax too.
What?
I never have white earwax.
Both of you. In my hands.
You want just a single one?
Wow.
Okay.
Good job.
So here is A, B, C. So B squared minus 4AC would be 5 squared minus 4 times 1 times 4.
Huh?
So would it just be 4 times 4?
Just hold on, just one step at a time. Okay, so B squared, our B is 5, so that's how I got 5 squared. 4 is just a part of the formula. A is 1. C is 4. So we have 25 minus 16, which is 9. So is that a positive number?
Yeah.
So we have 2 solutions.
Oh, that's easy.
Oh.
I think we have like 8.
2. I think we got.
If
2.
this number is bigger than 0, that means we have 2 solutions. That's it. That's what we're doing.
You just left him hanging.
Oh, I'm sorry.
Fail for now.
Alfred.
Okay. So now let's talk about number 8. ABC. Yes. What? That's fine. Okay, so now let's do b squared minus 4ac. Now, if b is negative, it is important that you put it in parentheses before you square it. Okay, so my b squared, notice how b is in parentheses.
Yes.
Minus 4ac.
The 4 is always going to be there.
The 4 is always going to be there. Do you have a question?
On the last problem, I think you made a mistake.
Why?
I feel it really wrong. Yeah, it's supposed to be minus 29, minus 16.
No, it's 16.
4 times 1 times 4, I'm pretty sure is 16. Right?
Yeah.
Did you do 1 plus 4 and then
They're all multiplied together. Okay, so like here, we have 9 minus 4 times 1 times 10.
I don't believe that.
What's 4 times 1 times 10?
Oh, 40.
Oh,
He's like 2.
which is negative 31. That is less than 0. So there are no solutions. Yeah.
So for the negative 4ac, is that just the negative mean that we're just subtracting, or are we multiplying that?
So it's minus, so it's subtracting. Yep. Okay, you do number 9. Yes, that's fine.
You guys get 1 solution?
All right. Eyes up here.
You're right.
Let's vote. How many say 2 solutions? How many say 0 solutions? How many say 1 solution? All right, Avery, what's B?
B is 10.
Sophia, what's A?
1.
And everybody, what's C?
25.
So we have 100 minus 100, which equals 0.
And if it's equal to 0, it's 1.
Good job.
Very good, Avery. Okay.
Good job.
Right.
All right, here's the deal. Hey, listen to me very carefully.
I want to know the deal before I accept it.
You have 8 graphs and 6 discriminants.
I don't accept.
You can choose to skip 2 graphs. You can choose to skip 2 discriminants. So instead of doing 15 problems, you're really going to do 11. You're going to do 6 graphs and you're going to do 4 discriminants.
But that would be 10.
Whoops.
Is it page 18 and 19?
I don't know why I can't count.
There.
Oh, number 1, you will also do, everyone will do number 1. That's why. So you'll do 11 problems. You'll do number 1. We're on page 18. Everyone will do number 1. 2 through 9, you need to do 6 of. 10 through 15, you need to do 4 of. You're welcome.
So would you just write the names of the things?
The 4 names. Yep.
Okay.
So we can cross out 2 for each like part.
Yep.
Alright.